It's about time to learn about space. Space is a cold, very vast place. Let's start local in our solar system. At the center is the sun that supports our existence. A long time ago they thought the earth was the center of the universe, the galaxy, the stars in all their splendor. Along came Copernicus, an astronomical tormentor. The church and ruling class saw him as a dissenter. The geocentric model Copernicus said wasn't true. The heliocentric model he developed and would stick to. He started on his own, then some evidence came through. Galileo's observations started changing the worldview. Through his telescope he made useful observations like the 4 big moons of Jupiter and their planetary relations. He saw Venus had phases and made the appropriate applications. All this evidence supported the heliocentric conversations. Then there's Brahe, a Danish astronomer who spent his nights observing the sky, an accurate recorder. Kepler worked with Brahe, though the relationship was strained. After Brahe's sudden death, his records Kepler gained. With them he proposed the planet's orbits are elliptical and several other great ideas with mathematical principles. By standing strong on evidence, they really paved the way. Due to the work of these guys, we know what we know today. Our sun holds us together in our planetary dance. Its gravity strong enough to cover quite a distance. 98% of all the matter in our solar system is found in the sun, which is mostly made of hydrogen and helium. Nuclear fusion is the process that keeps our sun a-going. Hydrogen combines into helium to make energy that keeps it glowing. The distance to the sun is a fact that is worth knowing. 93 million miles away is where the Earth is floating. The oval path around our sun takes 365 days to complete a single orbit and bring us back to our birthdays. The surface of the sun has some interesting features. They're hot enough to vaporize any living creatures. Sunspots are cool regions with cycles lasting 11 years. Solar flares are massive jets of energy from the photosphere. Prominences are looping arches of insanely hot plasma extending from the surface and returning to the miasma. The sun's atmosphere has 3 parts to speak of: the photosphere, the chromosphere, and the corona. The photosphere gives light and produces solar flares. The chromosphere looks red. The corona is the hottest part of the atmosphere. The sun's interior is 3 parts, but also a lot of unknowns. There's the core, the radiative, and the convection zones. The core is the place where nuclear fusion is a happening. The other 2 zones are where the energy is a traveling. In order to be a planet, you have to do 3 things: orbit the sun, be a sphere, and clear your orbit of everything. So with this in mind, the IOU puts our planet count at 8, but the demotion of Pluto is still a topic of hot debate. The inner planets are rocky and are closest to the sun. Unfortunately, it seems there's only life on one. Mercury is closest to the sun and is real hot. No atmosphere and crater pocked. Habitable, it's not. The temperature swing from night to day is super extreme. Long days, short years, radiation is a constant thing. Venus is considered the twin of our home planet, basically the same size but with a thick atmospheric blanket. Excess CO2 gives it a runaway greenhouse effect, warming up and trapping the heat, making it the hottest planet. The surface is hot enough that it will melt lead. With the temperature and the acid rain, this planet's likely dead. Earth is where we all reside. It seems the perfect place. At least it allows for survival in the frigid void of space. Mars is 4th and it's the last terrestrial planet. Iron in the soil makes it red. One day we hope to man it. It has 2 moons, even though it's half of Earth's size. It's got a thin atmosphere and polar caps of CO2 ice. To separate the groups of planets, there is an asteroid belt. Perhaps it used to be a planet, or perhaps it's something else. I know it's getting long, but our solar system's huge, and the outer 4 planets are the giants of the neighborhood. They're called the Jovian planets, also the gas giants. We've now sent probes to all of them thanks to rocket science. Jupiter's the 5th planet and the biggest one by far. 1,300 Earths would fit inside if Jupiter were a jar. Jupiter's gravity is so strong that it holds over 60 satellites. Its big red spot is a ginormous storm that's blowing day and night. Saturn is a planet best known for its rings. They're made of rocks and dusty particles and other little things. Saturn's still quite big, about 360 60 Earths. It has very low density despite its massive girth. Then we find Uranus, blue-green and full of gas. The color comes from methane, the same stuff that you pass. It's funny because Uranus seems to rotate at an angle. It's like it's rolling along through space, peaceful and tranquil. Neptune is our last gas giant, was discovered by math. Based on calculations, astronomers uncovered its path. Its orbit is extreme and the planet's very stormy. Beyond it is the Kuiper Belt, Pluto in weird territory. The dwarf planets aren't planets because they haven't cleared their orbits, whereas comets are made of icy gas and rock and little corbids. They circle the sun in the Oort cloud. Sometimes we can see them. It takes so long for them to orbit at the edge of our solar system.